solve this one, I'm going to label them equations A, B, and C again, as usual, for quick reference. And we have to pick one to solve for one of the variables. There are several variables here that would be fairly easy to solve for. X, Z equation. I'm just going to go ahead and I'm going to solve equation A for the variable Z. So 2x minus 3y plus Z equals 17. I am going to subtract 2x from both sides and add 3y to both sides to make both of those go away over here. So we get Z equals 17 minus 2x. My 7 got a little sloppy there. Let me rewrite that. 17 minus 2x plus 3y. That's equation A still, just been rearranged. Now we have to put that back into the other two equations. Let's look at equation B. X plus 2y. Instead of Z, I'm going to put in 17 minus 2x plus 3y equals 3. Now we have to solve that. First, we're going to combine what we can on the left side. The parentheses aren't doing anything. There's nothing to do inside the parentheses, nothing we can combine there. And there's nothing happening to the parentheses. So realistically, we can just take the parentheses out. They're not doing anything. Now we can combine x and negative 2x. That's negative 1x. 2y and 3y is 5y. And then we have the 17 equals 3. And I'm going to subtract the 17 just to get it in that form we're used to. So I have negative 1x plus 5y equals a negative 14. That's my new equation B. Now we're going to do the same thing with equation C. 3x minus y minus, instead of z, I put in 17 minus 2x plus 3y equals 11. Now here there is something that we have to do with the parentheses. Again, there's nothing to do inside of them, but there's a minus in front of them. So we have to do a negative 1 times that parentheses. So our 3x and our negative y don't change. We do negative 1 times 17 is negative 17. Negative 1 times negative 2 is a positive 2x. And negative 1 times positive 3y is a negative 3y. Equals 11. So now we have some combining to do. We have the 3x and the 2x. 5x. Negative y and negative 3y is negative 4y. We have a negative 17 here equals 11. And now I'm going to add 17 to get rid of that, to put this in that proper form. So I have 5x minus 4y equals 28. That's my modified equation C. So this gives us a new system of equations to solve, our two-variable system of equations. We have equation B, which is negative 1x plus 5y equals negative 14, and equation C, which is 5x minus 4y equals 28. And I can solve this using whatever method I want to. This one's actually relatively easy to use substitution on. I'm going to solve equation B here for x. Come on. There we go. So I've got negative 1x plus 5y equals negative 14. I'm going to subtract 5y. Negative 1x equals negative 14 minus 5y. And I'm going to divide by the negative 1 to get x by itself. So x equals negative 14 divided by negative 1 is a positive 14. Negative 5y divided by 1 is a positive 5y. So equation B becomes x equals 14 plus 5y. So I have to come back and put that into equation C here. So instead of 5x, it's 5 times 14 plus 5y minus 4y equals 28. And so now we're going to do some combining. We'll do the 5 times 14 is 70. 5 times 5y is 25y. The negative 4y is not in the parentheses, so it does not get multiplied. Still combining. 25y and negative 4y is 21y. That's positive. We still have the 70 up front. Equals 28. And then we'll subtract 70. We get 21y equals a negative 42. And then we can divide by 21. Y equals negative 42 divided by 21 is a negative 2. So we have y equals negative 2. We go back up here. We'll put that into this equation to find x. X equals 14 plus 5y. Well, we put the negative 2 in for y. X equals 14. 5 times negative 2 is a negative 10. 14 plus negative 10 is 4. So x equals 4. Then we go back up to this equation to find z. So z equals 17 minus 2x plus 3y. We put in 4 for x and negative 2 for y, and we solve. Z equals 17. 2 times 4 is 8, so that's minus 8. 3 times negative 2 is a negative 6, so minus 6. Or plus a negative 6, however you prefer to look at it. So now we have 17 minus 8 is 9. And 9 plus a negative 6 is 3. So z equals 3. So our solution here, x is 4 when y is negative 2 and z is 3. Well, that was a lot of work. Substitution can be a lot of work. Let's take the same system of equation, 2x minus 3y plus z equals 17. Just a touch. Room. X plus 2y plus z equals 3. And 3x minus y minus z equals 11. And again, I'm going to label these equations A, B, and C again for ease of reference. And I look at this system of equations here. Specifically, I look at the z variable. I have a positive 1, and a negative 1. This screams that addition or elimination method. That's exactly what I'm going to do with it. Over here, if I add equation C to equation A, so I'm going to do A and C here. A is 2x minus 3y plus z equals 17. And C is 3x minus y minus z equals 11. If I add those, 2x and 3x make 5x. Negative 3y and negative y make negative 4y. Positive z and negative z cancel out. Equals 17 plus 11 is 28. That's A plus C. Now you might notice that's actually the same equation we got when we substituted that solved equation A into C in the last time we did this. We got there a lot quicker here. That's one of our two variable systems, or two variable equations for that system. Now, the equation we have not used yet is equation B. We have to use that this time. And the key is we eliminated variable z this first time. We have to eliminate the z variable again this time. So I have my equation B, which is x plus 2y plus z equals 3. I need to eliminate the z again because that's what we eliminated last time over here. And I see that if I just add equation C to it, it's going to do that. D is 3x minus y minus z equals 11. And let's just do that addition. X plus 3x is 4x. 2y plus y is just 1y or y. Positive 1z and negative 1z is 0z. That cancels out. Equals 14. So over here, this is equation B plus C. That is my second equation for my two-variable system. Now over here, I'm going to take this bottom equation and multiply it by 4. Because if I do that, that'll make this a positive 4y. This is a negative 4y. They're going to cancel out when I add the equations. So 4 times 4x, 16x. 4 times y is 4y equals 4 times 14 is 56. That's my B plus C that's been multiplied by 4. My A plus C equation, I'm just going to keep. 5x minus 4y equals 28. And you can see why we're keeping it, because the y variable is going to be eliminated when we add the equations, when we do our addition. So 16x plus 5x is 21x. 4y plus negative 4y is 0y, that's gone, equals 56 plus 28 is 84. Now we can solve this for x by dividing by 21. X equals 84 divided by 21 is 4. Now I can use that to solve for y in one of these equations. I'm going to use this one here, the 4x plus y. So I have 4x becomes 4 times 4 plus y equals 14. Four times 4 is 16 plus y equals 14. And now I can solve for y by subtracting 16. Y equals negative 2. And I still need to find z, so I have to go back up to one of the original equations. Let's use this one. X plus 2y plus z equals 3. And let's fill in what we have here. We have x equals 4, so that's 4 plus 2y becomes 2 times negative 2 plus z equals 3. Well, 2 times negative 2 is a negative 4. Well, negative 4 plus, or 4 plus negative 4 is 0. That just cancels out. So z equals 3. So we get the same answer. X is 4 when y is negative 2 and z is 3. But in this case, this addition method allowed us to eliminate the variables rather quickly, and it was a little bit less work than the substitution method. Now, this system was set up perfectly so that one of the variables disappeared when we added the equation. That z variable, you couldn't ask for it to be more tailor-made than that. It's not always going to be that simple. So let's do 3x minus 2y plus z equals 9. 2x plus 2y plus 3z (21). and 3x minus y plus 2z equals 15. So now in this system of equations, it's not quite so obvious what variable we should try to eliminate. It's going to cancel out. Once again, I'm going to label my equations A, B, and C. If I'm looking for at least common multiple for x, well, I've got 2's and 3's. That would be 6. That wouldn't be terrible. For y, I've got 2's and 1's, so 2 would be our least common multiple. And for z, I've got 1's, 3's, and 2's. Again, that would be 6. That wouldn't be terrible either. I am going to choose to eliminate the y's. Now remember, what we have to do, the first step, we're going to combine two of the equations to eliminate the y. In the second step, we have to use the third equation that we haven't used yet, and then one of the other equations. So what I'm going to do is I'm going to combine here a and b. A is 3x minus 2y plus z equals 9. B is 2x plus 2y plus 3z equals 21. Now you'll notice here, I have a negative 2y and a positive 2y. The y is going to disappear. It's going to be eliminated. So we'll add 3x plus 2x is 5x. Negative 2y plus 2y is 0y. It's gone. Z plus 3z is 4z. Equals 9 plus 21 is 30. So there is the first. That's a plus b. That is the first of my two variable equations. Now the equation I have not yet used is equation C. I have to use that now. The variable I eliminated was the y variable, so I have to eliminate the y variable again. So here's what I'm going to do. I am going to use equation C along with equation B. Because C has a negative y, B is a positive 2y. I'm going to use equation B here. As it is, 2x plus 2y plus 3z equals 21. But if I add that with equation C, it's not going to totally cancel out the y. I need to combine it with 2 times equation C. So that means I'm going to multiply every piece in equation C by 2 as we've done before. 3x times 2 is 6x. Negative y times 2, we'll think of it, negative 1y times 2 is a negative 2y. 2z times 2 is 4z. And 15 times 2 is 30. Now the y will be eliminated when I add my equations. 2x plus 6x is 8x. 2y plus negative 2y disappears, it's 0y. 3z plus 4z is 7z. And 21 plus 30 is 51. So that's b plus 2c. That is my other two variable equation. So I'm going to bring those over here. I have 5x, 4z equals 30. Was a plus b. 8x plus 7z equals 51. Was b plus 2c. I have to now solve this system. Not going to be easy. If I look at my common multiples, 5 and 8 is going to be a 40. That's getting up there. 4 and 7 is going to be a 28. Either way, I'm going to have to multiply both of them. So let's take a peek, see what we have to do. Let's just pick a variable. I'm going to pick the z to get rid of. That means I'm going to multiply this one by a 7 to turn that 4z into a 28z. This one, I can't multiply by 4. That would turn it into 28z, but I need one of them to be negative, so I'm going to multiply by a negative 4. So the top equation here, a plus b. 7 times 5x is 35x. 7 times 4z is 28z. Equals 7 times 30 is 210. The bottom equation, my b plus 2c. Negative 4 times 8 is negative 32x. Negative 4 times 7z is a negative 28z. Equals negative 4 times 51 is a negative 204. So now we're going to go ahead and add those equations to see what gets eliminated. 35x plus 32x is 3x. Sorry, 35x plus negative 32x. 35 minus 32 is 3. 28z plus negative 28z is 0z equals 210 plus negative 204 is just a 6. Now we can solve for x quickly by dividing by 3. X equals 2. Now remember, when we go back to find our other variables, we have to go back to the next stage. Here we have one variable, one equation. I have to go back to the two variable, two equation stage, which is right here. So in one of those equations, I'm just going to do the top one. 5x plus 4z equals 30. And we now know that x is 2. 5 times 2 plus 4z equals 30. 5 times 2 is 10. Plus 4z equals 30. We're going to subtract the 10. 4z equals 30 minus 10 is 20. And then we divide by 4. Z equals 5. So now we have two of the variables. Now we have to go back to the three variable stage, which is where we started. One of these original equations to use to solve for the remaining variable. So I'm going to use b because everything's positive there. So 2x plus 2y plus 3z equals 21. And I'm going to substitute in x equals 2. So 2x is 2 times 2. Y I don't have yet. Plus 3z. Well, z is 5, so that's 3 times 5. Equals 21. So I'm going to combine. 2 times 2 is 4. 3 times 5 is 15. Keep combining. 4 times 5 is 19. So I have 2y plus 19 equals 21. I can subtract 19. 2y equals 2. I'm going to divide by 2. Y equals 1. So the solution I get here is x is 2 and y is 1 and z is 5. Now, just like any other equation and just like our two variable systems, if I'm unsure of myself here, I can go back to this original system and I can put in, what were those again? 2, 1, 5. I can put in here 2 for x, 1 for y, 5 for z, make sure I get 9. But I have to do it in all three equations. An answer could work for one equation, but not the others. So 2 for x, 1 for z, or 1 for y, 5 for z, make sure I get 21. Put in 2 for x, 1 for y, and 5 for z, and make sure I get 15 there. So we have to make sure we get those to work out. So you don't have to plug them back in to double check them, but it's a nice way to make sure you're doing it correctly. Well, we will do more examples of this tomorrow. I wanted to make sure I give you guys plenty of time for homework time to try these on your own. Your homework is that same worksheet that we did the substitution on for the last couple of classes. I want you to go back and use the addition or elimination method on those. So we got almost exactly 20 minutes left. Give you some time to start on the homework. I'll be on the network here if you need anything. Otherwise, if you would like, you are free to go.